Right now, the interstellar visitor known as 3I Atlas is cutting through the inner solar system like a silent storm. Its path is not a gentle glide. Through space, it's a head-on charge into the sun's dominion, where radiation, magnetic fields, and gravity merge into chaos. Discovered just months ago by the Atlas survey, this object has already rewritten what astronomers thought. They knew about travelers from beyond our solar boundary. Unlike comets born in the Oort cloud or Kuiper belt, this one didn't come from our neighborhood at all. Its trajectory proves it's a stranger from another star system entirely, and now it's getting dangerously close to the sun at speeds approaching 68 kilometers per second. 3I Atlas is moving faster than any probe humanity has ever launched, a blur of ancient rock and frozen gases slipping beneath the orbit of Mars. For perspective, that velocity could carry it from Earth to the moon in barely over an hour. Every calculation, every model, every observation tells the same story. This object won't loop back. It's on a one-way path through our solar system. The orbit's eccentricity exceeds 1, meaning this isn't a returning comet. It's a messenger passing through, never to return again. But this pass is anything but quiet. Its orbit tilts at about 175 degrees, a retrograde path that slices nearly perpendicular through the planetary plane, colliding head-on with the solar wind. The geometry alone hints at its alien origin. No local object moves like this. And yet, for all its measurable precision, much about 3I Atlas remains hidden. As it dives deeper toward the sun, its coma, that faint halo of gas and dust, thickens and brightens, cloaking the true nucleus beneath layers of activity. Early readings hint that the object could be anywhere between 5 and 50 kilometers wide, a staggering uncertainty that speaks to just how difficult it is to isolate its solid core. The sunlight that hits it is reflected through a haze of volatile carbon compounds, painting it in colors that shift nightly, from a deep crimson glow in early observations to a sharp green tint as it approaches perihelion. The transformation is a clue to its chemistry. Carbon-based gases like C2 and CN radicals dominate its spectrum, suggesting that carbon dioxide, not water ice, drives its activity. That's rare, even among the strangest comets we've seen. Now, as the countdown to October 29, 2025 approaches, the date of its closest approach to the sun, telescopes across Earth prepare for an unavoidable blackout. Soon the object will pass behind the sun's blinding glare, unreachable by even the most powerful observatories. For scientists, that means a stretch of anxious waiting. For the rest of us, it means this: the most mysterious interstellar visitor since Eid Oumuamua is about to vanish, and whatever happens on the far side of the sun, no one will see it in real time. As 3I Atlas disappears into the solar glare, astronomers face the kind of silence that tests patience and imagination alike. For weeks, every telescope on Earth from Hawaii's Mauna Kea to Chile's Atacama Desert will be blind to its motion. Even space observatories like SOHO, Stereo, and the Parker Solar Probe can't help this time. The comet's apparent brightness, estimated at only magnitude 12, makes it far too faint to stand out against the sun's violent background. The solar corona, filled with turbulent plasma and flashing arcs of light, drowns any trace of the interstellar traveler. Instruments must shut down automatically. Once the comet's solar elongation angle falls below safe limits, detectors can't risk exposure to direct sunlight. It's an enforced blackout, a data void stretching across October and much of November, and every scientist who has followed 3I Atlas knows it could be the most crucial gap of all. In that invisible window, anything might happen. The intense radiation and electromagnetic turbulence near the sun could ignite new outbursts, trigger surface fragmentation, or strip the object's coma into unrecognizable forms. Yet no one will see it unfold. Before the loss of signal, Mars orbiters Mars Express and Trace Gas Orbiter managed to capture a few long-exposure glimpses in early October. From their unique vantage points, those faint frames offered one last look before the light overwhelmed everything. The data are minimal, a blurred dot surrounded by an expanding greenish haze, no visible tail and no confirmed structure of the nucleus. Still, those snapshots hold clues. The coma's brightness curve continued to rise unexpectedly, even as the comet neared solar conjunction. Normally, comets fade as they approach intense heat, losing volatile material in rapid bursts, but 3I Atlas defied that pattern. Its increasing brightness hinted at fresh material erupting from beneath the surface, perhaps exposing regions never touched by sunlight before. That single anomaly has fueled intense, speculation in research groups and online observatories worldwide. Was it simple outgassing? Or something more dramatic, a breakup event hidden from direct view? For now, only mathematics and anticipation remain. Orbital models predict its perihelion at roughly 1.37 AU, just inside Mars's path, meaning it will not skim the solar surface like typical sun-grazing comets. Instead, it will sweep through the region where solar wind pressure and electromagnetic fields are at their peak, a natural laboratory for studying how interstellar materials behave under solar stress. Some plasma physicists see this as an extraordinary chance to test long-standing ideas about charged dust dynamics, while planetary scientists hope to detect post-perihelion changes once the comet re-emerges in late November. Every data archive from infrared scans to polarization, spectra is being prepared for comparison, waiting for that first reappearance. When the comet steps back into view, astronomers will search for any shift in trajectory, color, or brightness that might reveal what truly happened near the sun. Until then, the world of science holds its breath because at this very moment, an interstellar object larger than a city is flying through the most volatile region of our solar system, unseen, untouched, and utterly unpredictable. Mid-November will mark the moment the silence begins to break. As the sun's glare fades and dawn skies darken, Atlas is expected to reappear, fainter, colder, and forever changed. Telescopes across both hemispheres will turn toward Virgo, hoping to catch the first glimmer of light reflecting off a surface that has survived, or perhaps been reshaped by the solar encounter. No one can predict what they'll find. If the object remained intact, its coma may have collapsed into a thin shell of dust. The gas is frozen once more as it races outward. But if the heat fractured its surface, the reemergence could reveal fragments, scattering along its trajectory, faint points of light trailing behind the main body. Both outcomes will tell a story, not only of survival, but of how alien materials react to our sun's energy. The next confirmed milestone will come on December 19, 2025, when 3I Atlas reaches its closest approach to Earth. About 1.8 astronomical units away. That's still nearly 270 million kilometers, yet close enough for large observatories and space-based telescopes to analyze its after-effects in detail. Between those two dates, the reappearance and the Earth flyby, every night Sky Observer will be part of a global experiment in patience, waiting to see if this visitor has left behind a message, written in chemistry and light. Already, early models predict subtle deviations in its expected path. These could be caused by non-gravitational forces, such as uneven outgassing or electromagnetic drag from solar plasma. If confirmed, these shifts will help refine our understanding of how interstellar objects behave when crossing dense solar environments. Scientists are also keen to test the object's polarization, patterns, how its light scatters through space, to determine whether its dust grains are metallic, glassy, or carbon-rich. Such data might reveal whether 3I Atlas came from a stable planetary system, a dying star's remnant, or even the debris of a long-lost exoplanetary core. Each fragment of information, however small, contributes to a bigger puzzle, how matter travels between stars, carrying with it traces of worlds we've never seen. For now, the interstellar traveler continues on its hyperbolic path, leaving the solar system forever once it clears the sun's influence. It will drift into the cold again. Beyond the reach of our instruments, another silent witness to the universe's unending motion. For scientists, 3I Atlas isn't just an object, it's a cosmic question mark. It challenges how we define comets, what we assume about solar interactions,